Hi dear. So last class we have seen this atmospheric refraction and some of its phenomena like twinkling of stars, why it is appear higher than the actual position, and like advanced sunset, sunrise and delayed sunset like that. Okay. So today we'll see the scattering of light. Scattering means itself it spread in all the direction, right? Scattered, right? Scattering of light. What does mean by that is when a ray of light passes through a path of suspended particles. Okay, when a ray of light passes through a path of suspended particles like dust, gas molecules, water vapor, etc., it splits up in various random direction. Okay, this phenomena is known as scattering of light. Okay, for if you see, if a beam of light is passing through it, okay, it is moving in this direction. If it strikes a particle at this place, okay, now what happens, this splits up and it scatter at all the direction. Okay, it reflects. Okay, not all the rays will be reflect, some of the rays will pass through. So again, if you are having a if you are having another particle, means again the reflection will takes place in all direction and again it will go like that. That's why you are able to see a beam of light when it passes through a solution. Okay, glass containing solution, that too it should be a what solution? Colloidal solution. Only colloidal solution will contain a considerable amount of particle size so that it can reflect the light. Okay, it can scatter the light. Okay, if it is very very tiny, means we are not able to see the scattering of the light. Okay, so when a ray of light passes through the path of suspended particles like dust, gas molecules, water vapor, etc., it splits up in various random direction. This phenomena is known as scattering of light. Okay, so already told that the scattering of the light depends upon the size of the particles. Okay, uh, the path of a beam of light passing through a true solution is not visible. True solution means what? If in a glass of water, if you mix sugar, then it is a true solution. The particle, there are only tiny particles are present there, that it is very very small to scatter the light. Okay, but even we can say that we are not able to see the scattered light by the tiny particles. Okay, when the same beam of light is passing through the colloidal solution and it is visible, the colloidal solution is visible because the particle size is relatively large when compared to the particle size in the true solution. When compared to this particle size in the true solution, it is large, so it scatters the light and it is visible to us. Okay, this we have studied in the last year 9th standard itself, right, in chemistry. Tyndall effect, right? That is this thing. Okay, so this is scattering of light. What does mean by that? Scattering of the light means when a ray of light passes through the suspended particles, it scatters the light. Okay, it splits up in various directions. Okay, some of the phenomena of this scattering of light is we can see is Tyndall effect. Okay, and why is the color of the clear sky is blue and color of the sun at sunrise and sunset? Okay, we are going to see only the Tyndall effect and why the color of the clear sky blue in detail. Okay, not this color of the sun at sunrise and sunset. Okay, this just know the phenomena of the scattering of the light. Okay, Tyndall effect, same. Tyndall effect is the same thing, right? Scattering, if they asked in the 1 mark question, you can give this alone. Scattering of light by the colloidal particle is known as Tyndall effect. That's all, enough. Okay, they asked in 3 mark or 5 mark, you can go by this explanation. Okay, that means what? The earth atmosphere is a heterogeneous mixture. Okay, it is a homogeneous, it is a heterogeneous mixture of minute particles like smoke, tiny water droplets, suspended particles of dust and molecules of air. Everything is present in the atmosphere always, right? Always all the things will be present in the atmosphere. So what happens when a beam of light strikes such fine particles, the path of the beam become visible. Why? All the particles will scatter the light. Okay, The light reaches us after being reflected diffusely by these particles. Okay. This phenomena of scattering of light by the colloidal particles gives rise to Tyndall effect. Okay. Same thing, whatever we explained in the scattering of the light, that is your Tyndall effect. Okay. So some of the Tyndall effect where you can see this effect, that is when a light enters a smoke filled room. When sunlight enters a smoke filled room, you can able to see the particles, right? Particles will be suspended in the room, right? So how is that happen? When a fine beam of sunlight enter a smoke filled room through a small hole, okay, that's a scattering of light makes the particles visible. Even if you have noticed that if you have opened the windows in the morning, the sunlight will enter the room, right? If you dust anything, you can able to see the particles suspended in the air. When the beam of light is passing through, in the beam of light you can able to see the particles. Okay, can just even try. Okay, next where we can see this Tyndall effect is when sunlight passes through the canopy of a dense forest. If you had gone to a dense forest or a thick densely forest, you are able to see the light rays. Most of the light rays will be blocked by the canopy, right? Only few beam of light can enter through this canopy, right? So in that canopy you can able to see the scattering of light, right? When the sunlight passes through a canopy of a dense forest, the tiny water droplets in the mist scatter light. Okay, you can see that effect. Okay, so these are the two phenomena of Tyndall effect in our daily life. Okay, then we'll move to this color of okay. Well, we have seen the scattering of the light, and we discussed that the scattering is depending upon the size of the particles. Okay, and one more thing, the color of the scattered light, depends upon the size of the particles also. Okay, what will be the color of the scattered light? Okay, if it is scattered by very fine particles, means scatters blue light only. The small very fine particles can scatter only blue light, that is shorter wavelength light. Okay, blue light has a shorter wavelength. You know this VIBGYOR, right? White light contains VIBGYOR, right? In that, this blue light, right, it scatters the blue light. Okay, large size particles scatter lights of longer wavelength. Large size particles can scatter these things. Okay, longer wavelength. This is minimum wavelength, this is maximum wavelength. Red has maximum wavelength. Okay, and one more thing is how much times it is 1.8 times actually 1.8 times longer than the violet rays. Okay, next. Okay, if it is very small particles, mean it scatter the blue light. If it is a large particles, mean it scatter the longer wavelength. Okay, if the size of the scattering particle is large enough, so many particles are there means, and it's scattering means at a time, then you will get the scattered light would be white in color. Okay, each for example this area is covered with so many droplets of water. Okay, each droplet will scatter. Okay, based on the size of the particles or size of the particles, it scatters each light. Okay, all this you know the dispersion of light, right? All the 7 colors will combine to form a beam of white light. So at that time you can able to see the scattered light may even appear white in color. Okay, next, why is the color of the sky, clear sky, blue? Okay, so why is the color of the clear sky blue? Blue means what? Already told that very fine particles scatter the blue light, shorter wavelength, right? So that's why it appears blue in color. When sunlight passes through the atmosphere, the fine particles in the air scatter the blue color, that is shorter wavelength, more strongly than red. Okay, it first scatters the blue light only. Okay, thus the scattered blue light enters our eyes and sky looks blue. Okay, you may ask this vi VGR. Okay, why b this violet has even very minimum wavelength when compared to blue, but why it does not why the sky does not look violet instead of violet, why it looks blue means the sunlight has more concentration of blue light when compared to violet light. Okay, this is one of the reason. And our eyes are very sensitive to the blue light when compared to this violet light. Okay, so it looks blue. Okay, more concentrated blue lights will come from the emits from the sunlight when compared to the violet light. That's why it looks blue. Okay, next, what will be the color of the sky if there is no atmosphere for the earth? If there is no atmosphere means there will not be scattering, right? Because the atmosphere only contains dust particles, water molecules, air molecules, everything. If there is no atmosphere means nothing will be there, so light will not scatter, right? If the earth has no atmosphere, then there would not be any scattering, thus the sky would have looked dark. Okay, so this can be observed by few people. That is, the sky appears dark to the passengers flying at very high altitude. Okay, because the scattering is not prominent at such height. Okay, because there will not be any atmosphere, right? Next, why danger signal lights are kept red in color? Usually we can see this danger signal or the signal lights also, warning signals are kept red in color, right? Because you know that the longer red light has longer wavelength, right? Longer wavelength when compared to the other colors, right? So you know that if the if the light has longer wavelength, it scatters the least by the particles, right? Shorter wavelengths light only scattered most by the particle when compared to the longer wavelengths. So you know that red has a longer wavelength. Okay, danger signals are kept red in color because the red light is least scattered by the air, water, dust particles present in the atmosphere. That you know. Okay, it is least scattered. Okay, so if you keep the, hence red light is used as a warning signals or a danger signal because it can travel to a significant distance in the fog, rain and other conditions without being scattered or fading away. Okay, it can travel through a longer distance. Okay, for example, if you kept the signal here and you are here means, if you are here you are standing here means you can be able to see the red light or warning signal present here, because without any dispersion, any scattering, it can reach your eye. Okay, it can reach your eye. Okay, that is the main thing. And also you will get the same color, whatever red color is present means you can be able to see the same red color. Okay, that's why danger signals are kept in the red color. Okay, thank you.